Well, this isn't what we thought it was going to be, is it? Hey, you know, it's 2020, right? I thought you might like it if I walked you through these last few slides, so we'll try this. You let me know if it is good or if it isn't good, and we'll go from there. If you'll recall, we were playing with different sampling methods. We did that Justin Timberlake activity, and we did all kinds of cool little different stratification techniques, like stratifying by rows, stratifying by columns. We did cluster sampling. We did simple random sampling. So 4.1, we're talking all about sampling, all kinds of sampling things, ways to get data or get subjects so that we can collect data about them. So one of the most common alternatives to a simple random sample, and a simple random sample, man, that's like the gold standard. Simple random, everybody gets an equal chance of being in the pot, and you put everybody's name in the hat, and you stir them up really good and pull them out, and they got to be on the same size slips of paper so nobody has a disadvantage or an advantage. But sometimes that's difficult. If you think about trying to take a simple random sample of Tahlequah High School, there's like 1,250 kids at the school. If you want to take 30 of them, what does that look like? You got to get the list from Miss Matlock maybe, or one of the counselors. The list changes from day to day, depending on kids coming to school and dropping out of school, moving to new schools, and it's just a constant list that's in flux. So you pick a day and you say, I want this date, this time, that's going to be my list. We call that the frame, the sampling frame. You number the kids from 1 to 1,200 and however many we have, 1,250. And then you use a random number generator or a table of random digits, some device to pick certain random numbers. And say you get kid number 73. Well, now you got to go find kid 73. Then you get kid number 425. So now you got to go find kid 425. And then you get kid number 1,172. So, okay, let's go get that kid. And you got kid number 8. So you go get kid number 8. Everybody's got an equal chance of being picked. That is a simple random sample, which is sometimes difficult to actually pull off. So there are these other sampling methods we're going to talk about or try to formalize. One of the most common alternatives to the simple random sample is called the stratified random sample. You may say, well, what is a stratified random sample? What does that look like? Excuse me. Well, your strata are groups of individuals in a population who share characteristics thought to be associated with the variable being measured in a study. What? Oh, think of it this way. You put all your freshmen in one group, so that's a strata. You put all your sophomores in a group, that's another strata. You put all your juniors in a group, and that's another strata. And all your seniors finally, of course, go in a group. That's another strata. So stratas are just these groups of individuals in a population who share characteristics. Hey, the strata might be students and teachers. So you have teachers in a strata and students in a strata. But you're going to measure something. So if you have a question or a concern about parking at the high school, and you think, well, gosh, I think that freshmen might have different opinions than seniors do on parking and what that's like. Well, you'd stratify your population by those characteristics. Stratified random sampling, what does it do? Well, it selects a sample by choosing an SRS from each stratum and combining the SRSs into one overall sample. So sometimes you might stratify by gender, males and females. Sometimes you might stratify by, if you're a veterinarian and you're studying a new medication, maybe it's going to help your doggos. You might stratify by breed, because maybe you think that Chihuahua might respond differently to this new medication than the Great Danes will. So you can stratify that way, and then you just go get you a random sample of Chihuahuas. Go get you a random sample of Great Danes. Go get a random sample of German Shepherds, and begin to conduct your experiment. So stratified random sampling, select a random sample by choosing an SRS from each stratum. Again, SRS stands for simple random sample. Then you combine those into your one big overall sample, if you will. It might be this way. Maybe there's a concert that everybody wants to go to, and Ms. Wilson, your principal, she's got 12 tickets to give away. And she wants it to be fair. She doesn't want it to be like all freshmen that get the tickets, or doesn't want it to be all seniors that get the tickets. And so she decides to divide the school up by grades, sophomores, juniors, seniors, freshmen. And then because she had 12 tickets, each class, she's going to pull 3 winners out of each class. So she does a simple random sample of the freshmen, finds her 3 winners. Simple random sample of the sophomores, finds the 3 winners, and so forth, until she's got her 12 kids that they get to go to the concert for free. That's a stratified random sample. It works best when the individuals within each stratum are similar with respect to what's being measured, and when there are large differences between the strata. Think back to like the parking for the seniors versus the freshmen. Or maybe it's the cafeteria food. And it's you think that certain kids are going to respond differently. And so you break them down by their strata. before you get your simple random sample. We can choose strata that have similar responses within strata, but different responses between strata. So you want the within group to be more alike, and the between groups to be different from one another. Stratified random samples give more precise estimates than simple random samples. By precise, we mean you take that variation that we saw in our dot plots, like the Justin Timberlake concert. When we stratified by column versus stratifying by row, we saw a difference in the spread in that little sampling distribution that we created in those dot plots. So what we want is within groups to be more alike and between groups to be different from one another. That's when stratified random sampling works best. When populations are large and spread out over a wide area, this is another type of sampling we can talk about. We prefer a method that selects groups or clusters of individuals that are near one another. That's the idea of cluster sampling. So the thought of cluster sampling is this. It's hard to get a simple random sample of Tahlequah High School kids. So instead of doing that, how about all the rooms are numbered? Let's just pick an hour, like fifth hour, and let's just say we want to pick maybe 3 classrooms. So we put the numbers of the classrooms into a hat, we stir them up, and we mix them really well. They're all in the same size slips of paper. We reach in and we pull out, and room 116 is chosen, and that's the room that we're in here. And so fifth hour, they would come down to us, whoever's doing the experiment, and they say, hey, everybody in this class, we need to have you answer this survey question, or we want all of you to do this experiment for us that we're doing. And so you would do that. Everybody in the room is supposedly alike as much as possible, the rest of the population. And in your cluster, you say, well, this classroom is a cluster. And then also say room 403 was chosen. So you head up to the math wing, you get that room, and everybody in that room, fifth hour, they get to be in the study also. Maybe room 310 was chosen. So you head off to the science wing, and now all those kids are chosen. And if there are about 20 kids, let's say, in each of those rooms, now we've got 60 kids in our study. Oh, wait, room 128 was just chosen. So now we don't have 128. 228 was just chosen. So now we head off down to maybe around the corner where the Spanish is, and we take all those kids. They're a part of our cluster sample. Another place where you see cluster samples is airlines. So we want to know, what do you think of your experience on American Airlines today, or on Delta Airlines, or on Southwest Airlines? And so what we could do, it's going to be hard to get a simple random sample of airline passengers. And it might be hard to stratify also. You might, if you're just looking at the airline industry overall, you might stratify by airline. So you say, well, let's put the Delta people together, the American people, the Southwest people, put those groups all together, and then go get a random sample. But even there, cluster sampling is probably going to be a better way to go, where we say, hey, how about we take flight 1733 and flight 409 and flight, you name the flight number. Let's randomly select some flight numbers, and then let's give the survey to everyone on that flight. That would be an example of a cluster sample. We saw it in Timberlake, where you would randomly pick one of the 10 columns that the kids were sitting in, and then everybody in that column gets chosen. A cluster is just a group of individuals in a population that are located near each other. Cluster sampling selects a sample by randomly choosing clusters and including each and every member of the selected cluster in the sample. So that's one thing that makes it a little different. The random part is which classroom gets chosen, which airline gets chosen, which column or row gets chosen, and then everybody in that particular area, they get to be a part of your study. And cluster sampling works best when the clusters look just like the population, but it's on a smaller scale. So this little room of kids is just like all the other kids as far as whatever opinion you're wanting to measure. Cluster sampling is often used for practical reasons like saving you time and saving you money. So what can go wrong in these sample surveys? Well, we've learned, the use of bad sampling methods like the convenience or the voluntary response, they can lead to bias, which means that your estimates are not where they're supposed to be. They're just systematically off. So researchers can avoid these methods by using random sampling to choose their samples. So that's the idea behind random sampling. You want to try to use random sampling to minimize bias, so that you're just as equally likely to get this weird observation and this weird observation as any other observation, and that overall that would help balance each other out. But one of the problems in conducting sample surveys, that's sometimes there are things you can't avoid. They're more difficult to avoid. So we're going to talk about a few of those. Undercoverage is one. Undercoverage occurs when some members of the population are less likely to be chosen or cannot be chosen in a sample. And the thought there is like if you're going to just do random digit dialing, where you just like start dialing 918, 931 kind of numbers or 822 kind of numbers, and you pick 4 digits, well, that's good and all, but you're going to miss out on people that, 1, don't have a phone, or 2, maybe they don't have that prefix that you're dialing, because maybe they moved from some other town and brought their cell phone number with them, or moved from some other part of the country. Well, they won't even have a possibility of getting into your study, and you will have underrepresented them or undercovered them, that part of the population. Then there's the non-response that can lead to bias. And it's hard to avoid. Non-response occurs when an individual chosen for your sample can't be contacted or refuses to participate. So maybe you did a simple random sample in Tahlequah High School, and kid number 642 was chosen, and you figure out, hey, kid 642, I know where that kid is. I know who it is. So you go up to them and you ask them, hey, would you answer my survey? They don't want to talk to you. They think you're suspicious. They think it's sketchy. They don't know you. They don't have anything to do with you. That's a non-response bias because their opinion probably would influence your results. It's most likely it would, but they're not going to be a part of your study because they refuse to participate. You and I do this when we get one of those little random calls and we don't know who the caller is, and we just deny the call or send them to voicemail and don't participate in the survey or the study. So that is a non-response error or bias that can happen. And then there's response bias. That occurs when there's a systematic pattern of inaccurate answers to a survey question. Okay, so this one is the one where you intentionally, like somebody said you got to fill out the survey, and you just go down through there and you pick the first answer on all of them. Boom, 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 boom. That's a response bias. It's just a systematic pattern of inaccurate answers to a survey question. Or, hey, I don't want to take this test for this teacher, so I just choose C all the way down through there. Choice C. That is a response bias. You're actually responding. You're just not answering the survey. That's a response bias. I refuse to answer. That's a non-response bias. Hey, you didn't even ask me. That's under coverage. Okay? If you weren't even having a possibility to get in, it's under coverage. Refuse to give up an answer, non-response, and I'll answer, but it ain't gonna be right, is a response bias. So caution. Some students misuse the term voluntary response to explain why certain individuals don't respond in a survey. Their belief is that participation in the survey is optional or voluntary, so anyone can refuse to take part, but that's actually what we call non-response. So how do I avoid that issue? Don't use the terminology incorrectly on your AP exam. Just describe what's happening. Don't try to use the fancy words. Just say, hey, these people couldn't even get into the study because we didn't have their information. That's under coverage without you actually using the word under coverage. Or say, these folks wouldn't even answer us. That's a non-response. Or if you say, oh, this guy's answering his favorite like flavor of chewing gum is garlic curry pepper or something. You're like, what is that? That guy is giving you a response bias. You don't have to call it response bias. You just have to be able to describe it and why it's causing you a problem. And typically, you need to say which way the bias is going. If it's going to make your average higher or lower than the overall true answer, what it would be. So, things we're supposed to have learned in 4.1. To identify the population and a sample in a statistical study. Population's everybody. The sample is the small part of that population. Identify voluntary response sampling and convenience sampling. Voluntary response is like the radio show call-in or the newspaper respond to this online poll. Convenience sampling is where you just get the people around you. And then explain how those methods lead to certain biases. And typically it's whatever you're trying to estimate, whether it's going to be too high or too low. Describe how to select a simple random sample and doing that with some technology, either your calculator or some other random digit device, or a table of random digits. Describe how to select a simple random, describe how to select a sample using stratified random sampling and cluster sampling. Distinguish stratified random sampling from cluster sampling and give an advantage of each method. In cluster, often the advantage is that it's convenient. It's just cheaper or it's easier to implement. Stratified, the advantage is you get groups that are alike and that reduces your overall variability. Explain how undercoverage and non-response, question wording, and other aspects of sample surveys can lead to bias. And we played with that question wording one in class last Friday, the idea of asking you, hey, how's your life going? And then when was the last time you went out on a date versus when's the last time you went out on your date? And then, how's your life going? Question order is just as bad as question wording, where you go with a leading question. Question wording can sound like, Did you know the government's trying to take away your guns? Well, okay. How do you feel about protecting and preserving the Second Amendment? Well, then that's some question wording bias. You're leading them towards, well, I don't want the government taking away my guns. Versus another question, boy, guns out there, they're awful, and babies are dying everywhere, and kids and school shootings are horrific, and oh, it's just terrible, and all kinds of criminals have guns. How do you feel about making changes to the Second Amendment? Well, that would be a question wording bias as well, because now you're pushing the responder to give you an answer that says, no, we really need to give some attention to the Second Amendment and modifying it. Studies have been done where they give people the same question in a long survey, worded with this question wording bias, and people will give the exact opposite answer. You can really lead folks to give the answer that you're looking for. So that's a type of bias as well. Hope this helps, and you should be able to do the Samplng problems now, which I went ahead and made those due Thursday. So this will give you some time to work on those. Tomorrow I'll put up a Desmos activity for you. That's what's wrong with these surveys. It's pretty straightforward, just 3 slides for you to work with. Take care, and I'll touch base with you when we get ready to do 4.2 after Thanksgiving, hopefully.